So, good morning, ladies and gentlemen. As Peter's just said, my name's John Darby and I'm the Head of Technical Support at PASMA. I'm joined by Pete Harley, the Chair of the Hire and Assembly Committee. So, a lot of people think that towers are all the same. Well, in this session we'll hopefully show you the versatility of towers and what they can offer when they're built safely by competent users. We'll be using scenarios around safe working at height in a building refurbishment project and seeing how podiums and towers can help. So let's imagine a scenario. You're working on a building refurbishment project and you need to work safely at low level. You probably already reached for a podium, but you know how podiums are designed and the tests they have to pass. BS 8620 is the British product standard for a low-level working platform with one working platform, side protection to reduce the risks of falls from height, a maximum working platform of 2.5 metres, a safe working load of 150 kilograms, inbuilt access to allow users to climb safely to the platform, and supplied with a detailed instruction manual explaining how to use the product safely. They provide a safe method of working at low levels through the integral design of guardrails compliant with the work at height regulations and inbuilt stability to prevent overturning. They are commonly used in facilities management and the building trade to provide a safe and stable working platform at low levels. As well as the dimension and material requirements, BS 8620 is a product standard which is based on validation through physical testing. A podium designed to BS 8620 must withstand different loads and load combinations in order to conform to the standard. These tests include strength, overturning, rigidity, sliding, access stability, working platform strength, side protection strength, and access strength. If you're specifying and using podiums which are certified to BS 8620, you have confidence that they have been designed and rigorously tested for use in demanding work environments. So on our building refurbishment scenario, the work is now getting a little higher. You need to gain access to overhead M&E, air conditioning vents and some painting in an atrium. And here a mobile access tower would work well. So let's look at the standard for mobile access towers, which is EN 1004. Mobile towers to EN 1004 have a working platform height of between 2.5 metres and 8 metres for outdoor use and 2.5 metres and 12 metres for indoor use. They are constructed from prefabricated elements such as platform units that fix the dimensions of the tower, which is then horizontally movable on casters. They have platforms with side protection to reduce the risk of falls from height, which is also in accordance with the dimensional requirements of the work at height regulations. Towers have safe access methods to the working platform in the forms of vertical ladders, stairways and stair ladders, and they have stability provided in the form of stabilisers, outriggers or ballast. For many years, mobile towers have provided safe access for working at height due to their modular design and flexibility at work sites all around the world. Mobile towers must also be provided with a detailed instruction manual, and the manual must be in accordance with another standard, which is EN 1298. And it should explain how to safely assemble and use the tower, the components required for each platform height, safety information including working wind speeds, permissible side loads, and the number of permitted users, to name just a few. I think at this point it's worth mentioning that we continue to receive questions at PASMA sometimes about how to build a tower without a manual. And to be clear, without an instruction manual for the tower you're using, you don't have a tower, you have a pile of tubing that has the potential to be a tower. In addition to the requirements of the standard, PASMA has two recommended methods for the safe assembly and dismantling of mobile towers. These are known as advanced guardrails, or AGRs, and through the trap, 3T. The 3T method was developed by PASMA and its stakeholders when the work at height regulations came into effect in 2005. This was due to the need to have guardrails in place before a user stands on a platform. Prior to this, it was not unusual for the person assembling the tower to have to stand on the platform on the top rungs of the tower before adding the next end frames and guardrails. Over the last 10 years, AGR systems have become more popular due to the speed of assembly and the benefits of assembling the entire next level from the one below. Following the 3T method or an AGR system means that users should never be exposed to the risks of standing on an unprotected platform. All platform levels are double guardrail before the user stands on them, which reduces the risks and consequences of falls from height. AGR systems and the 3T method are used by all PASMA manufacturing members in the products they produce. We saw a little earlier that BS 8620 podiums are validated mainly through physical testing. EN 1004 is, however, slightly different. There are some physical tests, for example, the deflection of the whole tower or the guardrails, but the complete tower is verified as a structure through calculations in accordance with the structural design standards, and these are known as the Euro codes. EN 1004 contains the loads and load combinations, which must be taken through a structural design based on the corresponding material Euro code. This takes into account working loads and self-weight combined with wind, horizontal loads and safety factors for loads and materials. The structural calculation validates that the tower can withstand the loads from use as required in EN 1004. If you're specifying and using mobile towers which are certified to EN 1004, you have confidence that they've been designed and calculated for use in demanding work environments. I'll now pass you over to Pete Harley, who will then take us through the next of the session.
Good morning. Greater challenges. In our building refurbishment scenario, the challenges just keep coming. We now need to work over fixed cafeteria islands and ducting. We need to work safely at height on a stairwell, and we need to do some snagging jobs over a boardroom table on a suspended ceiling. You might already be thinking about other access products in these awkward scenarios, but towers can help you do these jobs quickly, cost effectively and safely. This is where BS 1139 Part 6 comes in. This is the British standard for scaffold towers, which use components from EN 1004 mobile towers, but in configurations outside the scope of EN 1004. Prefabricated scaffold towers to BS 1139 include no limits on working platform height or size. They can be static and built on base plates or horizontally movable casters. They use components from EN 1004 tower systems, which fix the dimensions of the tower, like platform units. All platforms are equipped with side protection, with safe access to the working platform. And finally, stability is provided in the form of stabilisers, outriggers or ballast, the same as the EN 1004. Or it can be tied into a suitable rigid structure, like a building, and made static. Prefabricated tower scaffolds are constructed using components you would find in a mobile tower, like braces, platform units and end frames. But the standard also has requirements for what's called enabling components. These are components which, when combined with mobile tower components, enable other types of structures to be built, such as walk-through frames, step-through frames, cantilever frames, beam units and bridge decks. Following the same approach as EN 1004, prefabricated scaffold towers need to be designed and calculated to verify the design meets the requirements of the standard. The enabling components form part of that calculation and analysis, supported by physical testing if required. BS 1139 is a wide-ranging design standard that does not set limits on what could be designed. For example, it does not say a cantilever scaffold tower needs to be of a certain height or size. What it does do is allow the designer or the manufacturer the freedom to design the solution that is required, whether that is for a specific application or a tower system with a product manual. Since the standard was published, there has been some confusion of how the standard is interpreted and what products or systems can be created. Over the past year or so, PASMA have been working on improving clarity over product categories and their requirements. These are split into two separate groups: standard configurations and non-standard configurations. So, standard configurations are tower scaffolds which come with an instruction manual, just like a mobile tower, and contain a similar level of detail and safety information. These configurations are not site or task specific and mean that anyone with the right competency can build the scaffold tower anywhere it is required. Standard configurations include cantilever towers, step towers and link towers. These are the ones which we have started with, thanks to the help from members, and over time may grow as other standard configurations are developed. Each of these configurations has their own risk and hazard beyond what is contained in the Towers for Users course. There continues to be a misconception in the industry that Towers for Users course allows card holders to build anything using mobile tower components. Through these standard configuration categories, supported by manufacturer member products, we can start to dispel this myth. And that is also why PASMA is continuing to revise and develop training modules to match these scaffold tower product categories. Let's look at each of these standard configurations, starting with the cantilever tower. These are particularly useful in gaining access over obstacles like refrigeration units or ducting. They come in two different types: end cantilever and side cantilever. An end cantilever has the cantilever platform extending outwards from the tower end frames, and access to it is provided with a step-through frame. A side cantilever has the cantilever platform extending sideways from the tower with the platform units running in parallel with the main tower. Towers with cantilevers must be stabilised to prevent overturning. The weight of the users, tools and materials on the cantilever section of the tower could cause it to overturn if excessive. So they are stabilised using either stabilisers or a ballast section fitted with weights or a combination of the two. All ballast weights must be of solid materials such as steel or concrete and must not be made of any liquid or granular materials such as water or sand. Materials like these are likely to be recycled on site even while the tower is in its use. And finally, for assembly and dismantling, the main tower and the stabilisation together with any ballast must be fitted first before the cantilever section is added or removed. Do not be tempted to remove the ballast first on dismantling. Next, let's look at towers on stairs, step towers. Step towers provide a safe means of access for working on stairwells. There are very few items of access equipment that can work on stairwells, and how many of us have seen a light fitting or an air conditioning duct in a stairwell and thought, how do they service those up there? Step towers have end frames offset, allowing the tower to be built on the stair flight. One of the challenges with building a tower on stairs is it could prevent people from using the stairs depending on the size of the tower and the width of the stairs. The risk assessment for using a tower on stairs should consider how can you evacuate the upper floor safely, especially if the stairwell is the only means of access. To make life a little easier, some manufacturers provide walk-through or portal frames which are fitted to the base of the tower. These allow access through the tower for those working on it and for the evacuation in the event of an emergency. Finally, let's look at towers with bridges. Linking towers together provides users with a large working area, for example, working on ceilings, or if there's a need to span a large obstacle, such as a boardroom table. Linked towers come in two different types, end and side, just like cantilevers. End-linked towers use standard platform units or longer bridging platforms to link two towers using the end frames. To allow the user's access through the tower, step-through access frames are used with gates and removable braces. Side-linked towers are used standard platform units fitted to bridging beams which span the gap. On both types, braces are added above the link section to provide full guardrails to the working platform. BS 1139, Part 6, 2014, non-standard configurations. The interesting part of the hire and assembly category. On the other side to the standard configurations, non-standard configurations are complex tower scaffolds which have been designed for a specific application. As these have been designed for a specific job, they would not come with an instruction manual, but instead must have a safe use assembly and dismantling plan written by a competent person. The plan usually consists of a drawing of the configuration with details of any ties, imposed loads, and some safety information. Method statement explaining how the tower scaffold design should be assembled, used, and dismantled safely. And reference to any relevant tower instruction manuals which could be used in reference for part of the assembly. Building a non-standard configuration to a drawing requires a greater competency level to safely build the scaffold tower. This is why PASMA recommend that non-standard configurations are assembled, altered and dismantled by those holding the Towers for Riggers professional certification. You'll be happy to hear that I'm now wrapping up the session, but in conclusion, I'd just like to summarise a few key points about working safely with towers. Number one, firstly, that following an instruction manual or safe use, assembly and dismantling plan, you are working safely with towers. Secondly, that by using access equipment in conformity with standards means you are working safely with towers. And lastly, PASMA's continuing work on the standard of categories of scaffold towers and aligning them with a competency level will help inform industry. It will provide a clearer message that simply owning a PASMA card does not provide you with the competence to build anything from tower components. Ensuring that users are competent for the equipment they are using means you are working safely with towers. We hope that this short presentation demonstrates that towers can do more than you think, but they must be used by people who have the right competency to do so. The tower showcase in the courtyard is an excellent demonstration of all the podiums and towers covered in this presentation. So during the coffee break and at lunch break, there will be plenty of opportunity for you all to have a look around and ask questions. Thank you for your time and your attention. Thank you.